You know, um, when you think about it, we generally operate on this fundamental assumption that computers are just perfect math machines.
Right. Like if you ask a processor what 2 plus 2 is,
It will always say 4 every single time.
which is, a comforting thought to get you through the day.
But if you dive into the sources for today's deep dive, that assumption is actually collapsing at the nanoscale.
It really is, especially when you look at the research coming out of 206 Innovation Inc. today, specifically around their CVP overlay processor.
And our mission here is to unpack how these, well, they call them mercurial cores, actually threaten the AI infrastructure you rely on.
Yeah, because we aren't talking about your typical blue screens or system crashes here.
No, we are talking about hardware that lies to you. The sources call it silent data corruption, or SDC.
And that silent part is the absolute killer.
Because a crash is at least helpful, right?
Exactly. A crash is just the computer screaming for help. SDC is when a bit flips inside the arithmetic logic unit.
Like a 1 just becomes a 0.
Right. And the processor just hands that wrong number down the line as absolute fact.
And this isn't as rare as I hoped. Google researchers actually coined that term mercurial cores because the chips pass all the manufacturing tests.
But then they just fail randomly in the wild.
Yeah, the data shows this happens in about 3.61 out of every 10,000 CPUs.
Which sounds like a rounding error until you realize hyperscalers are running millions of cores. At that scale, you're virtually guaranteed to have these ghosts in the machine.
The meta case study in the notes really drives that home. They had a defect where a chip started returning 0 for file sizes that definitely weren't 0.
And because the system thought the files were empty, it just skipped them entirely.
With no error flag, nobody looked. It went undetected for 18 months.
Corrupting millions of database records before anyone noticed. That is the danger of hardware rot.
But it's not just rot. Synchronization is a massive issue, too. The Knight Capital story is the one that always blows my mind.
Back in 2012, yeah.
They updated their trading software but missed one single server.
And that single node was running an old, stale version of a function called a power peg.
That is the stale state problem. Because the stack wasn't checking for that state, that rogue node went wild.
Losing the company $440 million in 45 minutes.
It bankrupted them.
But those are, in a way, legacy problems. With modern AI, we have a completely new headache with non-determinism.
Right, because we tend to think math is associative, that A plus B plus C is the same as A plus B plus C.
But on a modern GPU, doing floating point math, that rule breaks because of dynamic thread scheduling.
The GPU processes thousands of threads in parallel, and the order they finish changes millisecond to millisecond.
Exactly. So A plus B might happen before adding C one time and after it the next. You can run the exact same AI model twice.
And get slightly different numbers. And if you can't reproduce the result, you can't audit it.
Which brings us to the CVP overlay processor. It is designed to fix this exact chaos.
The documentation calls it a vendor-agnostic overlay. It acts as a safety net from L0 bare metal hardware all the way up to L4 governance.
It runs a constant loop. Sense, score, gate, and prove. Sense and score calculate metrics like integrity and risk.
But gate is where it gets active. It stops bad actions before execution.
Right, like preventing an autonomous AI agent from making an unauthorized wire transfer if that risk score spikes.
It doesn't wait for the error, it intervenes. But the proof phase is the real game changer for me.
The proof bundle. It is essentially a cryptographically sealed black box flight recorder for the chip.
Recording the seeds, the thread schedules, the exact weather inside the hardware when a decision was made.
Which solves the non-determinism issue completely.
You take that bundle to a different machine, and you force a deterministic replay. You replay the error exactly as it happened.
You aren't guessing why the AI failed. You have absolute mathematical proof. And that links directly to the economics.
NVIDIA H100 GPUs are sitting at around $40,000 a pop right now.
But utilization is often below 70%, mostly because of waste.
Because if a training run crashes halfway through due to a mercurial core, you scrap weeks of compute time.
But if CVP catches a stale state early, you save the run.
The ROI figures were pretty aggressive, paying for itself in under 7 months.
In high-performance scenarios, yes. It is an 81% ROI because you are moving from probabilistic detection
Just hoping you catch the bug.
to deterministic prevention, stopping the bleeding before it even starts.
It feels like a necessary maturity step. We are handing more control to autonomous agents, and we need a way to trust the ground they walk on.
We simply cannot build skyscrapers on shifting sand.
Which leaves you with a heavy question to mull over.
Yeah, Think about this as you go about your week.
In a world where autonomous AI agents run our infrastructure, is it enough to just know what the computer decided?
Or do you now need mathematical proof of why it decided that?
A completely different standard of truth. Thanks for joining us for this deep dive.
Catch you next time.